Hello everyone. In this video, we'll discuss the third problem of weekly contest 290. So this is a medium level question. The question name is count number of rectangles containing each point. So we are given an 2D integer array rectangles where rectangles of I contains two values Li and Hi. So this indicates that the ith rectangle has a length of Li and a height of Hi. So we are also given a 2D integer array points where points of j contains xj comma yj. This represents a point having coordinates xj and yj. So we are given a rectangles 2D array and a points 2D array. Uh, Now the ith rectangle has its bottom left corner at coordinate 0 comma 0 and its top right corner uh, at, at, at index li comma hi. Li comma hi is the values that we are given in the form of 2D array. Now all we need to do is return an integer array count of length points dot length. Now that means the value the length will be equal to the number of points that we are given, where the counts of j is equal to the number of rectangles that contains the jth point. So that means for each and every index in the answer, it will represent that how many rectangles contains this particular point. Now the ith rectangle contains the jth point if that particular point has its x index between 0 and the length of that particular rectangle and its y coordinate between 0 and the height of that particular rectangle. Now we also need to note that the points that lie on the edges of a rectangle are also considered to be contained inside the rectangle. So again, to sum it up, it's a question which says that we are given some rectangles, we are given some points. We need to find that for each point, how many rectangles contains those points. So if we look into the example, the first example, so we can see we are given three rectangles. Um, the the top right corner being 1 comma 2, 2 comma 3 and 2 comma 5. So you can see three rectangles represented by three colors. The one having a dark color, the second one a light one, and then again different color, sort of violet one. We are given a couple of points as well. It's 2 comma 1 and 1 comma 4. So if you look into the first point, it's 2 comma 1. So as represented by the green point in the diagram, we can see that two rectangles contains this point, the second one and the third one, because if you see this point lies on the edge of two rectangles. So the answer for this index will be 2. If I talk about the second point, it's 1 comma 4. So if we see this point, so we can see that only one of the rectangles contains this particular point. So again, it's 2 comma 1 the answer. That means the first point lies in two rectangles, the second point lies in the first, only one rectangle. Similarly, we have the second example. Again, three rectangles are given, 1 comma 1, 2 comma 2 and 3 comma 3 being the top right corners, and they are 2 points, 1 comma 3. Now if we see 1 comma 3, then it will be contained only in the last rectangle. And if we talk about the second point 1 comma 1, then you can see it will be contained in all the three rectangles. So the answer is 1 comma 3. uh, Now let's look into the constraints. It will help us in devising the algorithm. So the number of points or the rectangles that will be given is 5 into 10 raised to 4. Obviously each coordinate will have length 2, and then the length or the x coordinate of the point can vary from 1 to 10 raised to power 9. So I would say pretty large range in this case. However, if you see about the height of the rectangle or the yth coordinate of that of a particular point, it's just 100. So this is a very, I would say, notable thing which will help us in seeing that which algorithm we use or what could be our approach. Also the rectangles and the points are unique. So what I did was I took this line as the main point, and it helped me in devising the algorithm. Let's see what we can do. So the first thing that let's look into the example first. That what why I came to this approach. So if I tell you with example, yep, yeah. If I tell you with example, so there are rectangles which have Li and Hi. Now suppose the rectangles are as seen 1 comma 2, 2 comma 3, 2 comma 5, 5 comma 7 or whatever. Now if you see the length, that is the x coordinate can be very large. It could go up to 10 to the power 9. But the second, that is the height, that can have only 100 possible values. So if for every point we see, then a point can lie inside a rectangle only if the y coordinate of that particular point of that particular point is, I would say, is equal to or less than the y coordinate of a particular rectangle. Here y coordinate I mean the height of a rectangle. So these are the heights of the rectangle. And if I talk about a point can only lie inside a rectangle if the y coordinate of that particular point, obviously x also, but if I talk about the 1D first, then the y coordinate is less than or equal to the height of that particular rectangle. So and the values of a particular y coordinate or the height of a rectangle can go from 1 to 1 2 3 up to 100 dot 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 100. So now this is done. Now what about the x coordinate? Now x coordinates have pretty large values. It can go up to 10 raised to 9. So what we can do, what the approach that we can use is that for every height or for every y index or for every height of the rectangle, let's talk about the rectangle. For every possible height of the rectangle, that can be only 100 values, add the x coordinates or add the length of the rectangles in the form of a list. So it will be sort of a map. Map will have key as the height of the rectangle, and the value as a, again I've taken a tree here, I'll tell you why. So and the value for each height will be a map again, where the key of the map will be the length of the rectangle. We'll see why. The length, that means the value of the length of the rectangle, and the value in that particular map will be how many values, how many or that for that particular height, how many lengths are greater than this particular value. Let's see in the code for better explanation. So this is a map, let's call it a frequency map, and the key here is the height of the rectangle. So for every height we are keeping some data. Now what data? The value is a tree map, again a tree map with with the key being the length of the rectangle. That means for a particular hi, what are the lengths of the rectangle, and for every length of I, calculate that how many lengths are uh, greater than or equal to this particular value. Why greater than any equal to this particular value? Because what we can do, if we want to find that whether a particular for a particular height, for a particular height of a rectangle, whether a particular how many rectangles are there with a particular height which contains one particular point. That means for a given height, let's assume 10. For a given height 10, like suppose there are 100 rectangles having height 10 but lengths being different, ranging from 1 to 10 raised to power 9. And if we have a point which has, suppose, y coordinate is 50, so or for simplicity let's take 100, because the height we are considering is 100. So how many rectangles can contain it? So simply this transforms into a 1D problem, and all we need to do is check that how many lengths are greater than or equal to the x coordinate of the particular point, right? So for calculating that in O1, we need to do some pre-computation. Now that pre-computation is something like, for every height, cal for every height keep a map, and that map will contain the length of the rectangle and the number of rectangles with that particular height whose length is greater than or equal to the current length, right? How we'll do that, we'll see in the code. So this is the map, this is the use of the map. We have taken a previous count, we'll see why. Now we start traversing the map. Also, just one thing, one of the main things, in the first I've sorted the map, sorted the rectangles. So as explained, we have sorted the rectangles based on the height of the rectangles. So in the form of increasing height. However, if 2 points have same height, then if two rectangles have same height, then we sort them in decreasing order of length. We'll see why. The main reason being that we need to calculate how many rectangles have length greater than or equal to a particular value. So we have sorted it first based on increasing order of height and then decreasing order of length. Then we start traversing the rectangles, and we have taken a previous count. I'll tell you why. So the current length and height of the current rectangle is this one. We check whether the current height is present in the map or not. If it is not present, then just add it, add a tree map, add that particular key and add a tree map, and then make previous count equals to 0. Now why this previous count is used, we'll tell. Then we fetch the map for the current height, and then what we'll do, we'll put the current length and the count that was here, the variable that we took, and increment the count. Why we are doing it? Because we have sorted the array and in decreasing order of length. Now if it's the for a particular height, if it's the first value, that means it will be the maximum length for a particular height. Then what will happen, there will be no length for this height which will be greater than the current length, right? So the previous count is 0, and if I talk about the current length, then the number of lengths greater than or equal to the current length will be only 1. So that's why we increment the count. The previous count in this case was 0, we increment it and put it to 1, and then we update the map. Now let's come to the second iteration. In case of second iteration, again, if we find that the current height is present, then we are good to go. And then what we do, the previous count in that case will be 1, because the last time we did it for current height, we incremented the count. And then again, if for a particular if for a particular height the previous length was suppose 20 and current we are seeing 10, so that means how many lengths are greater than or equal to 10? That will be 10 plus the number of values that you have seen previously for this height. So the previous count was 1, you increment the count and you put 2 in that. Now as soon as we see a new height, obviously that height will not be present in the map. So what we do, we add that to the map and make previous count as 0. So for every height we are resetting this value and for the same height this value keeps on incrementing. So our map will be something like, for each height we will have the lengths, and for every length we'll have the number of values greater than or equal to the number of rectangles greater than or equal to the current length. So this will give us the result in O1. Now let's see how. So now we are done with this. Now we start traversing for each point. All we need to do is that see what is the current index of this point, and then you just see this loop. Now this loop starts from current height, because the current point has y index as current h, and the maximum value it can have is 100. So we start traversing from current height to 100, because obviously for this point to be contained in a triangle, the y coordinate of that particular triangle needs to be equal to or greater than the y coordinate of the point. We check whether the current height, that means the current y coordinate is present in the map or not. If that is not present, we skip it, because that means for the current height value we don't have any rectangle, right? So we just skip it. If we have that value, we check that for the return me the lengths, the second part. Return me the value for that current height, which will be again a tree map having length and the number of values of rectangles, the count of rectangles greater than this particular length. Now what we do, we have a function ceiling key. So it tells that how many values are, or I would say, if for a current value cur length of I, what is the value which is equal to or just greater than this particular value. So this function gives us the key in the map, whose value, whose not value but key, whose key whose key is equal to or just greater than this particular key. So we'll get the key. Now if this is the largest key, why we are doing so, we'll just see again. So if this is the largest key in the map, we get null, so we skip it. If we do not get null, then we just check this condition. Obviously this condition can be skipped. I added it because I was facing some error and I was trying to debug. The error was somewhere else, but again, and then we can add this value. Now this is the value that we calculated, so we can just return the answer. Now let's see why we are doing it. As explained above, what we can do, for if suppose 10 is the index, 10 is the I would say x index of the current point. So what we need to do, we need to find the rectangles for this particular height whose x index is either 10 or greater than 10, right? So what, and the key is the index, right? The x coordinate is the key. So that means we need to find the key which is just greater than or equal to 10. So if 10 is present, then well good, but suppose 20, 21, 23 is present. So we see the just the greatest value from 10, so it comes out to be 20. And then we see this will return as this will return us the number of rectangles for current height whose length is greater than or equal to 20, because 20 is the just 20 is the possible value for this particular iteration. So we just add it to our answer, we just assign it, and then return it to the answer. I know the explanation of this question was, I would say, pretty tough to explain without a diagram and all. But again, if you have any queries, then please do mention that in the comments. I'll try to resolve each and every query. And hope you learned something new from this video. Do subscribe to the channel, and please add any comments if you have any queries, and I'll try to resolve those. Thank you. See you in the next video.